Hello everybody. Now we are going to discuss about chapter light. So in this chapter we'll be discussing about lens and its types. So lens, it is a piece of transparent glass or plastic that is bounded by two spherical surfaces. It is used in different optical instruments like microscope, telescope, camera, etc. And there are two types of lens. Example, convex lens and concave lens. The first lens that we are discussing is convex lens. So convex lens that you can see in the picture. So it is thicker at its center and thinner at the edges. So such lens is called convex lens. And when parallel beam of light is passed through this lens, then what happens is all the rays of light, they meet at a point. So since the rays of light meeting at a point, so such lens is called converging lens. And it is of three types: biconvex lens because its both surfaces are bulging out; concavo convex lens because one side is bulging out and the other surface is depressed in. So such lens is called concavo convex lens. And the third lens is plano convex lens because one surface is plane and other surface is bulging out. Such lens is called plano convex lens. Similarly, concave lens. So this is a lens where the center part is thinner and edge is thicker. Such lens is called concave lens. And when parallel beam of light pass through it, the rays of light diverge into different directions. So since rays of light are diverging into different directions, it is also known as diverging lens. Like convex lens, it is also three types: biconcave lens because both surfaces are concave, and second lens is convexo concave lens because one surface is bulging out and other surface is concave shape. That's why it is called convex concave lens. And the third lens is one surface is plane and other surface is concave type. So that's why it is called plano concave lens. Now lens, it is uh, it is considered that it is made up of multiple prisms, which you can see in this picture in both convex lens and concave lens. So the general understanding is that when ray of light passes through prism inside the glass and outside the glass, in both condition, the rays of light is bending towards the base. Like inside the glass also you see the ray of light is bending towards the base of the prism, and outside the glass also it is bending towards the prism. That means when ray of light passes through prism, the rays of light bend towards the base of prism. So same concept we apply in convex lens as well as concave lens. So question may come, why convex lens converge the rays of light? Similarly, why concave lens diverge the rays of light? The reason behind it is that convex lens or concave lens, they are composed of multiple prism. So you can see in this convex lens, so this part, the base is down, so ray of light is bending down. And if you look at this prism, its base is upward, so that's why the ray of light is bending upward. So what happens that the rays of light, they meet at a point because of bending in opposite direction. But if you look at the concave lens, then this prism has base upward, so rays of light will bend upward. And here the rays of light, this prism has base uh, downward, so that's why the rays of light will also bend downward. So in this case, the rays of light are bending to different directions, so that's why the rays of light never meet. So this is the reason why when the ray of light passes through convex lens, the rays of light meet, and when ray of light passes through concave lens, it helps to diverge the rays of light. Now let us discuss some of the terminologies that we will be discussing frequently in ray diagram. So first of all, let us learn about the center of curvature. So as we discussed in definition of the lens is made up of two spherical surface. You can see here in convex and concave lens. So they are made of two sphere, and if there is a sphere, then there are two center as well. And those centers of sphere by which lens is made up of, that center is known as center of curvature. It means one lens has two center of curvatures which are given the name C1 and C2. The next term is principal axis, the straight line. It is imaginary line and it passes through both center of curvature. So it is a straight line which passes through both centers of curvatures is known as principal axis. Optical center, the point on the principal axis which is lying at the center of the lens is known as optical center, and it is represented by O, and this is also the center of lens, so it will be here optical center. Now focus, as we discussed before, when parallel beam of light passes through convex lens, they meet at a point, and when parallel beam of light passes through concave lens, they diverge from a point. So that very point from where the rays of light appear to diverge in concave lens, or the point where the rays of light meet, that point is called focus. And this focus is represented by F, you can see capital F, and focus is lying always on either side of the lens, means both side of lens, exactly at the midpoint between optic center and center of curvature. It lies in the midpoint. Now focal length. Focal length is the gap between optic center and focus is known as focal length, and it is represented by small f. Capital F represents focus and small represents focal length, and its value is positive in convex lens because focus is real, and in concave lens its value is always taken in negative because the focus is not real, it is virtual, so that's why the focal length is taken in negative value. Now before drawing ray diagram, we need to know certain rules. So rule number one is when ray of light passes through lens by being parallel to principal axis, you can see this ray is passing through lens by being parallel to principal axis, and in concave lens also it is passing through the lens by being parallel to principal axis. In this case, if it is convex lens, it always passes through focus, and in concave lens it will not pass through focus, but it appears to diverge through focus. This is the first rule. The second rule is that either convex lens or concave lens, if the ray of light passes through optic center, it passes without bending. And the third rule is when ray of light passes through focus in convex lens or appear to pass through the focus in concave lens, how does it pass? It passes by being parallel to principal axis. So this rule number 3 is just opposite of rule number 1. Now let's discuss about ray diagram of convex lens. The first condition is object at infinity. So infinity means very far distance. So from the far distance all the time the parallel beam of light will come, and when it passes through the convex lens, then it will follow rule number 1. So what will happen? They will pass through focus. That means the ray of light will meet at focus. So image will form at F on other side of the lens. So nature of image is, it is real image because this image is formed by crossing of real rays, and if real image, it is always inverted. So real image is always inverted, and you can see the size it is forming in point means it is highly diminished. Now second condition, object beyond 12. So in every step we are coming more closer. So in condition 1, object was very far, that's why it was object at infinity. And second step, now we are coming one step closer to convex lens, so that's why it will be object beyond 2f. So one ray always goes parallel to principal axis. So according to rule number 1, it will pass through focus, and other rays goes through the optic center, and according to rule number 2, it passes without bending. So they have meet here, the point where the rays of light meet, exactly their image will form. So image has formed between F and 2F. So that's why language is written when object is placed beyond 2F. So this is 2F, beyond 2F, image is formed between F and 2F on other side of lens. So nature image you can guess, since it is formed by crossing of real rays here. So this is real image. A real image means inverted, you can see. And if you look at the size, you can also guess the size. Image is smaller than the object, so smaller means it is dimness. Now condition number 3, now we are coming closer. In condition, if object was beyond 2f, now object at 2f. So same concept, one ray is parallel to principal axis, it passes through focus. Another ray goes from optic center and it passes without bending. So they are meet here. So this is one special condition when object is 2f, image also from at 2f but on other side of lens. For that your measurement has to be accurate. So nature image, it is also real image because it is formed by crossing of real rays, you can see, and whenever real image it is inverted, you can see this also in figure, and size will be almost equal because object distance and image distance are equal, so it is equal size. The next condition is object between F and 2F. We are coming closer and closer. So what happens? Same, when one ray go parallel, it passes through focus. Other ray goes from optic center, it passes without bending. So two rays they have meet here. So the image has formed beyond 2f. So means when object is between f and 2f, image is formed beyond 2f on the other side of lens. Nature image, it is real image because it is formed by crossing of real rays, and it is inverted. And you can see the size. It is image is bigger than object, so it is magnified. Now condition 5. Object at f. So you can see object is at 5. One ray goes parallel to principal axis, it passes through focus. Other rays goes from optic center, it passes without bending. So two rays of light, they are parallel to each other, so they will not meet here immediately. So when they are extended, they might meet somewhere at far distance. So image will form at far distance. That's why it is believed that image is formed at infinity, because image is forming at far. So nature image, what it is believed that these two rays of light will meet at far distance means they will meet. That means real image. And if real image, it is inverted. And since it is forming at very far, so it will be very big. So that's why it is highly magnified. The last condition of convex lens is object between F and O. So you can see, as usual, one ray goes parallel, it will pass through focus. Other ray goes from optic center, it passes without bending. So as you go on extending, they are diverging. So this side they are never going to meet. So when you produce them back, they meet here. So the point where these produced rays meet, their only image will form. So this image is different than the previous conditions. This image is not formed by real rays. This image is formed by the produced rays, not real rays. That's why it is not real image. It is virtual image. And virtual image is always erect or upright. You can see it is upright. And see the size, it is bigger than object. So that's why it is magnified. And where the image is formed behind the object. Now let's talk about ray diagram of concave lens. There are just two conditions. The first is object at infinity. As we discussed before, from the infinity, the parallel rays will come. And according to rule number 1, if the ray of light passes through lens, it will appear to diverge through focus. So it will diverge in this way. And this ray also will appear to diverge through focus. So this side they are not going to meet because they are diverging. So when you produce them back, they are meeting at F. So it means image is forming at F on same side of lens, because image is object also here, image also formed here. So nature image, it is image is forming by produced rays, so it is virtual image, and virtual image upright or erect, you can say. And since image is forming in points, so it is highly diminished. Now the last condition of concave lens. So here either you keep beyond 2f, at 2f, or between f and 2f, or at f, or between f and o. Wherever you keep, image will always form between f and o. That's why it has not got any multiple conditions. So only one condition is created, that is object in front of lens. So you can keep object anywhere, beyond 2f, at 2f, between f and 2f, at f, wherever you keep, but the image will always form between f and o. So you can see this is the object. So one ray will go parallel to principal axis. So according to rule number 1, it appears to diverge through focus. The other ray is going through optic center and it passes without bending. So this side, these two rays will never meet. So when you produce them back, they are meeting at this point. So image will form here. So means the image is forming between F and O on same side of lens. So nature of image, since it is formed by produced ray, so it is also not real image, so it is virtual. Virtual means erect, and you can see the size of image, it is smaller than the object, so means it is diminished. So with this, we finish ray of diagram. So let me tell you, in all the exams, out of 8 ray diagrams, 1 is sure in exam, so that's why prepare properly. Now power of lens, either it is convex lens or concave lens. What they do is, if convex lens, it will converge rays of light, and if it is concave lens, it will diverge rays of light. So each lens has got different capacity to converge or diverge the rays of light, and this very capacity is known as power of lens. So that's why definition of power of lens is the converging or diverging capacity of lens is known as power of lens, and its value is positive in convex lens because focal length is positive in convex lens, and its value is negative in concave lens because value of focal length is negative in concave lens. And it is mathematically reciprocal of focal length of lens. So formula is P equals to 1 by F. And the SI unit of power of lens is diopter or radian per meter. Now question may come, what do you mean by 1 diopter power of lens? So when do you get 1 diopter power of lens? If focal length is 1 meter. So that's why it means if lens has focal length 1 meter, then power of lens is considered as 1 diopter. Now uses of lens. So use lens in various purposes. The first is it is used in different optical instrument like microscope, camera, telescope, mobile phone, like that. It is used to correct defect of vision. Convex lens, it is used to in magnifying glass that you can see. And concave lens, it is used in peeping hole of the door. Now magnification of lens. Just now we studied about ray diagram, and you have seen the lens is making different size of image, sometimes highly diminished, sometimes diminished, sometimes equal size, sometimes magnified, sometimes highly magnified. So the process of forming different size of image by lens is known as magnification of lens. So it has two formula. So m equals to I by O or m equals to B by U. So I means your height of image, O means height of object. Similarly, B means image distance from the lens, and U is object distance from the lens. So we can use any formula, but normally we use the second formula to calculate magnification. And since it is the ratio of same quantity, it has no unit. And normally magnification has three possible values. It can be equals to 1, it can be less than 1, it can be more than 1. See, if value of m comes exactly 1, that means the image size is equal to size of object. But if the value of m comes more than 1, then image is magnified than the object, and if the value of m comes less than 1, then the image is diminished, means it is small in size than the object. Suppose question came, lens has magnification 2, what does it mean? Here magnification 2 means it is more than 1. So more than 1 means it is magnified. That's why what we'll say, it means image is magnified by the lens 2 times. Now let's have short description about human eye. Human eye body is oval in shape, and it is also considered as optical instrument because it has convex lens in it. The ray of light will pass through conjunctiva, the outermost covering, followed by cornea, and then it will reach aqueous humor, the water-like liquid, and then pupil, and here lens, and this gel-like liquid is vitreous humor, and finally it will reach the most sensitive layer of eye, that is called retina, where the image will form. And the image that is formed on the retina is real, and if real, it is always inverted. And whatever the image is formed on the retina, that message is carried by optic nerve to the brain, and brain will see the object. Now, accommodation of human eye. So human eye sees far object and near object. So whenever eye is observing far distance, then our eye lens must have long focal length, and when human eye is observing near object, then eye lens must have short focal length. That means our eye lens keeps on changing its focal length according to the distance of object. So this capacity of eye lens to adjust the focal length according to distance of object is known as accommodation of human eye. And how it is done? The lens is supported by ciliary muscles. So if you are observing the far object, then ciliary muscles will contract and eye lens becomes thinner, which helps to increase focal length. Similarly, if you are looking at near object, then the ciliary muscles will relax, and because of relaxation, the lens become thicker, due to which eye lens become shorter. The farthest point up to which a normal eye can see the object clearly, that is known as far point of vision, and for normal eye, it lies at infinity. Similarly, near point of vision, the nearest point up to which a normal eye can see object clearly is known as near point of vision, and it lies 25 centimeter far from the eye. So range of vision, it ranges from infinity to the 25 centimeter. Now defect of vision. So as we said, whenever distance of object is changing, the focal length of eye lens also must change. For example, if eye is observing far object, eye lens must have long focal length. Similarly, when eye is observing near object, eye lens must have short focal length. So if our eye lens fails to change the focal length according to distance of object, then that time the eye will have defect of vision. So there are two types of defect of vision that we'll be discussing here. One is short-sightedness, another is long-sightedness. So here you can see this is the object in front of eye, which is near. So here the rays of light from the near object, it is exactly focused on the retina. Means this eye is able to see near object clearly. But the second figure, the parallel rays of light always comes from distant object, far object, and the rays that is coming from the far object, it is focused before the retina. That means this eye cannot see far object clearly, but can see near object clearly. So since this eye can see near object clearly, but not far object clearly, such defect of vision is called short-sightedness or nearsightedness or myopia. The causes is that to see the far object, eye lens must be thinner, but it always remains thick. Because of that, this defect of vision is caused. And sometimes what may happen that maybe eyeball was this much big. When eyeball was this much big, the focus was exactly on the retina. But sometimes what may happen is the size of eyeball may get bigger, and when it gets bigger, the retina goes back, and because of that also the defective vision causes. So how to correct it? So here the focus you have to shift on the retina, and to shift this focus behind on the retina, the rays of light must diverge. So concave lens is only the one which can diverge. So that's why in this case we'll be using concave lens to correct this defect of vision with proper focal length. So here's the diagram to correct this defect of vision. Similarly, uh, here the parallel rays of light that is coming from the far object, it is focused on the retina. I mean, this I can see far object clearly, but the object which is just in front of eye, means near object, the focus is not on the retina. I mean, this eye is not being able to see the near object clearly. So this is the defect of vision, where near object is not seen clearly but far object is seen clearly. Such defect of vision is called long-sightedness or farsightedness or hypermetropia. And causes is, to see near object, eye lens must be thick, but here eye lens always remain thinner, and because of that this defect of vision is caused. And sometimes what may happen is, when eyeball was this much big, then focus was on the retina. But because of some conditions, if the eyeball gets small in size, then retina will shift forward. So due to that, the focus cannot take place on the retina, and this defect of vision is caused, and that is called contraction of eyeball. So here, to, to correct this defect of vision, the focus must be shifted forward on the retina, and that is possible when the rays of light will be converged. And the converging is possible only with the convex lens. That's why it can be corrected by using convex lens of proper focal length. So you can see the correction diagram. The convex lens is used of proper focal length to correct this defect of vision. With this, thank you so much.